Hey guys, welcome to Pre-Calc lesson 9.10, Trig applications. Our first example, Memphis, Tennessee is due north of New Orleans, Louisiana. The latitude of Memphis is 36 degrees 6 minutes north, and the latitude of New Orleans is 30 degrees north. If the radius of the Earth is 3,963 miles, how far is it from Memphis to New Orleans? Well, first, let's do a little Earth science review. Talk about latitude. So, say that is our globe, Earth, and here is the equator. Lines of latitude are parallel and start at the equator and go to the poles. If you remember, the equator is 0 degrees and the North Pole would be 90 degrees. So think of the unit circle. So if they're talking about Memphis and New Orleans, let's see, New Orleans is 30, so about right there. There's New Orleans. And Memphis is a little bit north of that. 36 degrees 6 minutes. And what we want to do is we want to find the distance along the Earth from New Orleans to Memphis. Okay, well, really what this is an arc length question. Think about the center, the circle. There's one radius, there's another radius, and because the Earth is curved, I want to find the arc length. So I can boil it down to this. S equals theta r, where theta is going to be in radians. Okay, well, what do we know? I know the radius, 3,963. What I need to find next is theta. That's pretty easy to find. I know New Orleans is 30 degrees north latitude, and Memphis is 36 degrees 6 minutes. So to get theta, I just need to subtract those. 36 degrees 6 minutes. I know you can do this in your head, but just for future reference, you just subtract those and you get 6 degrees 6 minutes. So that's my theta in degrees. Don't forget, we need to take that and convert it to radians, because in order to use this, that has to be in radians. And I'll multiply that by pi radians over 180 degrees and throw all of that into the calculator. Now, it might take a little bit of time because remember, you have to do your second apps, which is your angle menu, to enter the degree symbol there. And then you also have to go back to second angle and get your minute symbol. If I throw all that into the calculator, and what does it say to round to? It doesn't say, I'll go nearest tenth. I got 421.9 miles. Obviously, that would be like straight line distance, but kind of a cool application of trig. There's the arc length. Okay, next, the function s equals 22.3 minus 3.4 cosine pi t over 6 represents sales in thousands of units as a function of time in months. Using t equals 1 for January, find the months with the maximum and minimum profit. Doesn't ask for what it is, we just need to find the months where that occurs. So if you notice, this equation is written just a little bit differently than what we're used to seeing, but you'll see this quite often when they put our vertical shift in the front. So basically this means up 22.3. It's a negative cosine. Amplitude is 3.4. And my frequency is pi over 6. So the first thing I want to do is just write down the pertinent information in the progression we normally do. Amplitude, 3.4. Remember, that's always positive. My frequency, in terms of waves per 0 or between 0 and 2 pi, is pi over 6. The period, 2 pi over pi over 6. Copy, change, flip. I'll write that out just to show you. You guys can probably do it in your head. Is going to be 12. Which kind of makes sense, right? We're talking about months, so I'd like that to be 12. Makes it a lot easier to work with. And I know I have a vertical shift up 22.3. So what I'd like to do now is just make a quick sketch of one cycle. Here's my y-axis, here's my x-axis. To label my x-axis, I like to take my period and divide it by 4 blocks. So that's pretty easy to do, and that's 12. I got 6 there, 3 here, 9 there. Now, we have a vertical shift up 22.3. So something that I do, I just find it easier. I just make this 22.3. Sometimes I forget to actually do the shift, and then I don't necessarily want to see a graph where I have to go up 22.3 and then sketch something in, way up here. I just find it easier to make this midline 22.3 and just label that with my X values. All right, so if my amplitude is 22.3, I need to take, my amplitude is 3.4. So I need to go up 3.4, which basically just means take 22.3 plus 3.4, and that's going to be that value right there. Okay, so that's 25.7. Now to get this value here, I'm going to subtract the amplitude, and that's going to be this value right there. And I do that, I get 18.9. Next thing I like to do is just make a quick thumbnail sketch of one cycle. It's negative cosine. So here's a negative cosine curve. I know the length of one cycle is 12, so I just need to transfer these points here. There's no phase shift onto my grid. So I've got a point here, there, maximum's at 6, back to your midline, and to your minimum. Concave up, concave down, and back to concave up. So there's one cycle. Now find the months with the maximum and minimum profits. So we're assuming profits are tied to number of sales because that's what this represents. So I would say for max, that's pretty easy. 6, which would be June. Now, one thing we have to be careful of, and they made it easy here. 1 is January. Sometimes they make 0 January, which is a little bit more confusing in my mind because I'm thinking of the month number, 1 January, 2 February. This makes it nice for that reason. So 6 is the 6th month, June. The min, you gotta be careful, that's going to occur in December. 0 is December, right? If 1 is January, then going backwards, that's December. It's also the same as 12. The 12th month is December. So here and here, those two represent the same month. So max occurs in June, min occurs in December, and we just answered that question. Our next example is a little bit easier. This is a straightforward right triangle trig application. It says a ramp is to be built to provide disabled people access to a building if the angle of inclination must be 22 degrees and the entrance door is 4 feet above ground level. How long must the ramp be? How far from the base of the building should the ramp begin? So anytime you have a ramp, it's a simple, like I said, right triangle trig application. As you're looking at this diagram here, obviously this represents the ground. This is your ramp. And then this distance here is like the height of the door, the stage, whatever it is you need to access. All right, so according to this problem, it's 4 feet. But notice, if you read all the way to the end, find both to the nearest inch. This is in feet. They want things to the nearest inch. So you have a couple options. Number one, you can work with feet for the whole problem and convert to inch at the end by just simply multiplying by 12. Or if you don't want to worry about it at the end, you think you might forget, 4 feet is 48 inches. So I'll probably just be working with 48 inches for my height. What do we know? The angle of inclination must be 22 degrees. This is your angle of inclination right there. So it's got to be 22 degrees. And the first thing we'll find, how long must the ramp be? Let's put an X here. Remember your right triangle, SOHCAHTOA. This is the opposite side. That is the hypotenuse. Opposite over hypotenuse is sine of this angle. Simple equation. Sine 22 degrees equals 48 inches over x. When x is down low, switch and go. All right, remember that's a proportion. You can interchange the extremes and the means. So x is going to be 48 inches divided by sine 22. It's already in inches. All you have to do is plug this into the calculator. Please make sure you are in degree mode. You have to go back and forth in this unit. All right, once you're in degree mode, I will plug that in and round to the nearest inch. For that ramp length, I got 128 inches. Okay, next, how far from the base of the building should the ramp begin? So we're talking about this. Here's the base of the building. There's where the ramp begins. I want to find that distance there. Let's call that y. And for b, we'll get an equation that looks like this. Let's see, what is y? Y is adjacent. There's my angle, and that's opposite. I would avoid, you could use this. I would avoid it though, because number one, we had to round it, and number two, it comes from a calculation that I might have made a mistake on. So if it's not necessary to use a calculated value, I would avoid it. And we can here very easily. Like I said, that's opposite, that's adjacent. We're going to be using tangent here. So tangent of 22 degrees equals opposite 48 over y. Same type of equation, switch and go. So y equals 48 over tangent 22. And it's already in inches, like we said. Plug that in and you get 119, which makes sense. It better be less than the length of that ramp, because the ramp is the hypotenuse. This has got to be shorter. And those of you that remember your geometry, notice this angle here is 22 degrees, which is going to be much smaller than this angle. So this must be our smallest side. That better be our middle side, and that better be the longest side. And that's exactly what we found here. Our next example is probably the most challenging one we'll have today. It starts out by saying, at Ocean Tide Dock, the first high tide today occurs at 2 a.m. with a depth of 5 meters, and the first low tide occurs at 8:30 a.m. with a depth of 2.2 meters. Sketch and label the graph showing depth as a function of time, starting at t equals 0 being 12 midnight. B, find a trigonometric equation that models this function, and C, what will the water height be at 10 a.m. This is traditionally the most challenging type of application, judging by test results in past years. I think because you're given a couple data points and you have to create a trig model. Now, we make it a little bit easy for you because we always will give you a max and a min, or two maxes or two mins. So the first thing we need to do is set up our axes so that we can plot these two data points. 2 a.m., depth of 5 meters, that's the first high tide, so that's a max. It's a high point. And notice it says the first. The first low tide occurs at 8:30 a.m. with a depth of 2.2. All right, so I've got to scroll a little bit to sketch this, but the first thing I want to do is kind of sketch this situation. So this will be part A. My y-axis, here's my x-axis. Now, what I notice here is that the high is 5. That's my maximum. The low is 2.2. Now notice how I'm doing this. And I did this a couple examples ago. I know there's a vertical shift here. So the first thing I do is find what the midline is. What I would do is take 5 plus 2.2, throw out my calculator, divide it by 2. 5 plus 2.2 is 7.2, divided by 2 is 3.6. So that's my midline. All right, it's not the x-axis, that's my midline. So now what do? I have to figure out a scale for my x-axis. What does it say about the first high tide occurs at 2 a.m.? T equals 0 is midnight. So I'm assuming we start at 0 and we have to label by hours. So let's do something like this. There's 2. First high tide. So there's that data point right here. Well, let's just keep going with this scale. 4, 6, 8, 10, 12, 14. Let's see what we have from here. Now, not so easy because of this fun fact, 8:30 a.m. Look at my scale. I don't have a grid here. I'm not detailed enough, but I know 8:30, let's see if that's 9, 8:30 is right about there, is the first low tide. So that data point is going to be here. Now you might be thinking, well, how the heck can we do this if I don't know what this scale is precisely enough? Here's what we know. This is a max, so my function does this. Here's a min, so my function does this. Somewhere in between, it's got to cross. And it starts down again, but it's not going to cross. And then it goes up here and does something like so. First thing I'm going to do is figure out what is this distance. That's not hard to do. That's 8.5. Here, I'll write it down. 8.5 minus 2. Well, that's 6.5. So this distance here is 6.5. What does that represent for this function? A high point to a low point is exactly half the period. So to finish this cycle, I would have to go another 6.5 in this direction. Well, this is 8.5 plus 6.5, add those together, and you get a 15. So then I know my next high point would have to be at 15. So I need to just go out one more here, 16. And at 15, I'm right here. So what did I just calculate? Notice I'm not sketching this in yet because I want to make sure I calculate exactly where it crosses the x-axis. That's going to be important. But I know this is a high point. I know that's a low point. I know my next high point is here. So it does something like this. It's kind of a poor sketch, but you get the idea. Let me finish that. So I do know one thing. I know the period is 6.5 plus 6.5. The period is 13. I do know my amplitude. 5 minus 3.6 is 1.4. So I'm getting there. I could actually create an equation now with one exception. That's the first maximum. It does not go back down to 0. It hits here. So what is that telling me? That's telling me there's a phase shift. Right 2. If I'm starting at a maximum here, that looks like a cosine curve to me. So it's a cosine curve, shifted right 2. My amplitude is this. My period is 13. So what does that tell me about the frequency or the b value? 2 pi over 13. So I'm actually finding this first. I haven't found these values, and maybe it's not critical enough, but I do need to make a sketch. I'll find those in a second. But I can actually write this. Find a trig equation that models this function. Okay. Y equals, I said it's a positive cosine. Amplitude is 1, so 1.4. Cosine. My b value is 2 pi over 13. Times, there's a phase shift right 2, x minus 2. And there's a vertical shift. I didn't even label that, but notice here's my midline. A vertical shift up 3.6 plus 3.6. Okay, so it's quite a bit of work to get that. I want to sketch this in real quick, so here's the easiest thing to do. Notice if this distance between the max and the min is 6.5, it's going to cross here at half that distance, 3.25. All right, so 3.25 from here is 5.25. It'll be approximately right in there somewhere. And then from 8.5, I have to add 3.25. So what's that, 11.75, so it's going to be real close to that. Now I can get a pretty accurate sketch. Notice you're not given a grid, and they're going to ask you to create these sketches without a grid because they want you to use your numbers. And that should bring this back a little bit to there. They want you to calculate these. They don't want you just to count them on a grid. They want you to be able to calculate how far this is from that on the x-axis. They want you to know that that's 3.25. They want you to know that maximum to minimum is half the period. So if you find that distance, you just double it, and there's your period. Okay? So we got the sketch. And then lastly, C. This should be the easy part. What will the water height be at 10 a.m.? So one thing you notice here at 10 a.m., it's not the min, it's not the max, it's not the midline. I have no idea what this is by the graph. If you try and ballpark this, you're not going to get full credit. This question would be calculator active, and they want you to understand that at 10 a.m., your value for x or for t, whatever it is going to be 10. So all you need to do is use the function that you created and plug in 10 for your x value. All right, so show that works. So there's C. It's going to be y equals 1.4 cosine 2 pi over 13. Now, I know you know 10 minus 2 is 8, but I'm just going to plug it in to show you where I'm plugging it in. Now, the one thing, actually, there's two things. When you go to plug this in the calculator, you need to put parentheses here. Right? The calculator will automatically insert parentheses after cosine. You have to put your 2 pi over 13 and then another set of parentheses for your 8. The other thing, radian mode. So we were just in degree mode for the application before. Now I need to shift to radian mode because guess what? This is in radians. So if you plug that into your calculator, and it doesn't say what to round to. Usually on a calculator active, it'll say like nearest 10th or nearest 100th. I went 100th here, and I got 2.55. And I guess we're talking meters for your depth. And that should kind of make sense. You can sort of ballpark 2.55. Like, there's no way I could get that precise from here, but I know, oh, it's got to be greater than 2.2, and it's got to be a little bit less than 3.6. So yeah, 2.55 kind of makes sense. It seems like it would be closer to this 2.2 than that just visually, and it is. All right, one more. This last example is actually much easier than the one we just did because we're given the trig equation. Given a of t equals 220 minus 50 cosine 2 pi over 24 t minus 6. Find the maximum minimum value. So I put that question first because I want to find the maximum minimums without looking at the graph. And it's very easy to do. And I don't know if we've formally stated this, but to find the max, you simply take your vertical shift plus amplitude. To find your min, you take your vertical shift minus amplitude. And it's important for this one, you start with your vertical shift. I mean, you should start in both cases because you realize this is really the midline. So you take your midline and go up whatever the amplitude is. There's your max. Take your midline, subtract. Because if you change this order, you get the wrong answer. So very easy to do. The maximum is your vertical shift. So we talked about it also in the last problem. They put it first here. You could tack this on the end as a plus 220 and then not have it there. But this is kind of a common notation. So vertical shift is 220. Amplitude is 50. 220 plus 50 is 270. There's my max. My min, 220 minus 50. What's that? 170. Easy. Next, sketch one cycle identifying all key information. So let's do this in red. First thing I know, amplitude. We always do that first. Is 50. We just talked about it. Frequency is 2 pi over 24. And some of you guys can tell me what the period is without even doing a calculation because we did one like this in class. 2 pi divided by 2 pi over 24. You do your copy, change, flip. And the 2 pi's cancel, and that's just 24. So some of you might have remembered in class when I said you see 2 pi over something quite a bit in these trig applications. Whatever's in that denominator is the period because these 2 pi's end up canceling. So if it's 2 pi over 365, the period is 365. Okay, next, what else do we need here? We've got a phase shift of right 6. So let me jot that down. Phase shift, right 6. And we got a vertical shift of, what was that, up 220 if I remember? Yeah. Okay, quick little thumbnail for this. It's negative cosine, which looks like this. The period is 24. And we are shifting this right 6. So let me use a different color. This point right here is going right 6. So let's quickly set up our axes. This won't take long at all. I like to do the x first, pretty easy. The period's 24. It's a great number to work with. Then go half of that's 12, half of that's 6. 6 plus 12 is 18. So there you go. There are your 4 blocks. I like to take my vertical shift and make that the midline. Right, this is the midline, and I'm making this the midline. So it's not 0 on the y-axis. That would be 220. This value up here is your maximum, so you could add 50. Remember, well, I just did that up here, so that would be 270, and the one down there would be 170. So that's 270 there. That's 170 there. And now, lastly, I am just going to take these key points, the min, the max, sorry, the mid, the max, the mid, and the min. And really, we just have to take this first one and move it right 6. Well, that would be here, right 6, it goes here. So this, oops, sorry, I'm doing this wrong. This point is this one, sorry. Right 6, there would be my minimum. What's nice about cosine and negative cosine is that you're starting at a maximum or a minimum. So I know to get my next key point, I'm going to be going up, whether I go in the positive direction or the negative direction. So that's going to give me my mid value. The next block would give me my max, and the next block would give me my mid. So I'm just going to be following this pattern. Remember, that pattern just continues on and on and on. So that would be mid, that would be max, that would be mid. But one thing I don't want you to do is just leave your graph like this, or even just go on from here. It's not hard. Let's bring it back to the y-axis. Just go backwards. Simple. Not the best graph, but simple to get that point. So finally, actually we got 2 more parts here. C, write another equation for a of t without a phase shift. And this is a cool concept. When I look at this, I don't see negative cosine. We were given a negative cosine function. But because of the phase shift, it makes it look like something else. So when I look at this, I see negative sine. Like, oh, it's negative sine without a phase shift. So it's easy to write down now because what doesn't change from the original? The vertical shift does not change. The amplitude does not change. The frequency does not change. So all of these will be the same, except I see a negative sine and it does not have a phase shift. So there's my equation. Oh, okay. All that stuff, I don't need to do any work. That's simply going to be y equals 220 minus 50 sine, in parentheses I'll put this, 2 pi over 24 t. Oh, you know what? I should make this a of t. Sorry, I forgot my function notation. So this equation right here is the exact same as this equation. We would say those are in phase because it just gives you the exact same graph. And then finally, if t equals 0 is midnight, at which times do the maximum and minimum occur? So let me write down max and min first. Max at, min at. Okay, so here's my maximum. What time is that? 18. Well, if you remember, if this is midnight, this is noon, so that would be 6 o'clock p.m., and you have to mention a.m. or p.m. Or, if you want to consider military time, I would say something like this, 1800 hours. That'd be like military time, which is on a 0 to 24 basis. Minimum. Okay, minimum occurs right here. The minimum occurs at 6 o'clock a.m. So that would be 6 o'clock a.m. All right, and that finally concludes day 10 notes. As usual, guys, if you have any questions, please don't hesitate to reach out. Thanks a lot for watching, and we'll see you in class soon.